Hey Mo,
Hey, Ricki.
the doctor is in.
Yes, we are. It is a very special Sunday edition during Touchtober, during Breast Cancer Action Month, during all the things. Some people call it Pinktober. I don't care what you call it, as long as you get your mammogram. Talk to your
Right.
family and your friends about breast cancer this month and beyond. But it's a special episode today, and I'm like fangirling out today. I got to tell you, this is so exciting. I'm glad you put this show together because, we got to talk about the research. That's why you
Do.
started Touch, right?
Yep, we do. And it's really thank you for your magic touch. Thank you for your magic touch because these two brainiac, beautiful women are doing magical work. And it's just, they're making magic every day and they're changing lives, they're saving lives, and they're going to make their mark on our world and really are doing amazing things. So we're so happy to have them. So we have Dr. Melissa Davis. And Mo, when I was making the flyer this week, I couldn't fit all the stuff on the flyer. Like their titles are so many lines. I was like, I got to make the font smaller because they do so many things. So Dr. Melissa, she's on our medical advisory board. We're so happy to have her. And she's doing a major work at Will Cornell. And then we have I call her my child, Dr. Hadiyah Green, because she's such a precious baby. I met her when she's such a precious baby. And she's in Atlanta at Morehouse Medical School doing amazing work, breakthrough science. And the science, I always say the science is what's going to save us. The numbers for our mortality are just horrific. And until we get the science right and make things for our bodies and understand what's going on with us and our bodies, we're not going to save Black women from breast cancer. So or really all cancers, right? So all the research is done on, we got 3% participation in clinical trials for Black women. So we have to do better. And these ladies are breaking the odds, just doing incredible work. So you guys do go ahead.
I was just going to say, let's back up a little bit because I think when people hear those words, clinical trials, right? There's a lot of misnomer, a lot of misunderstanding, a lot of fear surrounding it. And I'm a breast cancer surgeon. So by the time I'm introducing a trial to patients, many times they don't realize that this isn't something we just thought of yesterday, but this has been vetted and it's been explored, and it started from an idea, and then it started in a laboratory, and then from a laboratory and from petri dishes and cancer cells like the HeLa cells, right? Henrietta Lacks cells. It may then go into an animal model, and then from an animal model, then we may try it in human. And it's a whole process that goes into designing things that people use today, whether it's like you say, Tylenol and Advil, right? Or whether it's something as serious as like chemotherapy or estrogen blockers that we use now to prevent cancer recurrence. There is an entire area of research, of science, and there's a lot of work that goes into these trials. And I just want people watching to kind of put that into perspective, because this isn't so new and so unexplored, and it's not that it hasn't been vetted, but people tend to think that just because it's the first time they're hearing about it, that is brand new, right, Doc?
Right.
Yes, and I need to add something because I am not authorized to speak on behalf of my day job employer. I am not here representing Morehouse School of Medicine. I am here as the founder of the Ora Lee Smith Cancer Research Foundation. I just want to at the top of the show make that clear that I have more than one role, and today I'm wearing this hat.
Absolutely, and thank you for that. So we'll
that hat.
definitely get that in perspective.
Yeah, thank you for that. And your work is so important, and you're so right, Mo, that we have to do this work. So Melissa, tell us about yourself and what you do, and then we'll get into your work.
Hey, well, first of all, thank you for inviting me back again. I love spending time with you guys. So my name is Melissa Davis. I'm a molecular geneticist by training. I'm a genomicist as well. We can talk about that, but really all it means is that I look at all the genes in the genome simultaneously. I'm really interested in why we see very aggressive forms of breast cancer and prostate cancer, particularly in African Americans here in the United States. Forgive me for the background, by the way, I'm on location, so hopefully you can hear me. But what we're starting to find, like you mentioned, is that because there hasn't been, there's been a deprioritization, so to speak, of minorities in cancer research, such that now we don't fully appreciate the diversity in what's happening when we, diagnose tumors, treat tumors. And so we're busy across the African diaspora. So I'm the scientific director of an international program, and we study breast cancer and prostate cancer in Africa, in the Caribbean, South America, and across the United States. So, we'll dig in a little deeper later, but that's the gist of who I am.
Wow.
And I'm wearing all my hats today.
All your hats. So many hats.
Yeah.
So many
Even
hats.
my mom hat. Yeah, all my hats right now.
Yeah, the mom
Very
hat is the most
important hat to wear.
That's the most important hat to wear. That's the most important hat to wear. Yeah, gotta have those birthday parties. Okay, Dr. Hadia.
Yes, first let me start by saying I am super excited to be here. Ricki, I love you like a mom, like a sister, big sister. It's always special to share this moment with other Black women who are fighting the good fight to help us win this war on cancer, especially to bring awareness for breast health during the month of October. This is a special time of the year. And when I was younger, I didn't like Halloween. So taking over October for breast cancer awareness is something that I actually feel good about celebrating. So my background, all 3 of my degrees are in physics, and I developed technology using the type of technology that makes cell phones and computers work and apply that to targeting cancer at the site of the tumor using lasers and nanotechnology, which is like Star Trek, it's the next generation of cancer treatment. And it's really, when we think of Wakanda and Shuri, the Black female scientist in Wakanda, I felt like she was my representation on the screen of doing that next level of science to move research beyond hope, beyond chemicals, to use technology the same way that Madame Curie, who invented the X-ray machine, revolutionized the way we image the body. That's what I hope to be for cancer, to revolutionize the way we treat cancer. Oh, and I'm the founder of the Ora Lee Smith Cancer Research Foundation. So I have some other titles, but we'll stop there.
So you guys, you're doing amazing work. How many physicists like you are there in the world, Hadia?
So
break down the number.
I'm one of the first. Last I counted, maybe I think 3 or 4 years ago, we finally got to 100 Black female physicists on the planet.
Wow.
And so I would venture to say that there's still less than 110 or 120, just because there are only a few every few years. So it's something that, when people think about physicists, they automatically think about Albert Einstein, not Dr. Hadiyah Green. And I'm moving to, say, okay, we have Neil deGrasse Tyson, but we don't have like the household name brand of what people think about when they think about physicists. And most people who are doing cancer research come from a biology background or a chemistry background, but STEM is a broad world, and you can take all kinds of innovation to introduce new ways to solve different types of problems. And so I like to encourage people to think outside of the box, because I look like a scientist, I look like a doctor.
Oh, I love it so much, because we got our hashtag for surgeons, hashtag I look like a surgeon. And I mean, less than 4% of Blacks in medicine, and less than 2% in surgery, and less than that Black women in surgery. So, I totally get it. And I love to see you representing and talking about not just the research, but about your specialty and about how doable it is, because people sometimes will look at who we are and what we do, and they may say, you know what, that's not for me. And I talk to kids a lot when I do the career days and things about changing your approach, and how, failure is not necessarily an indicator that it's something you shouldn't do, and how we sometimes will discourage ourselves and our young people before they get a chance to explore that interest.
Yes. And I tell people when I'm speaking at, career days and things like that, I didn't test well. I wasn't really strong at standardized testing. My strength came in my ability to sit down for a long period of time and concentrate. And I have extraordinary problem solving skills, but I don't have the best memory. And if you were to measure my intelligence based only on my memory, some people may say I'm not that smart, but that's not my strength. And a lot of times we tell our young people, if they are not smart the way that some people think you should be smart, that they don't have any room to contribute intellectually. And I'm, a prime example of, don't put God in a box with how you show up on the planet, because my strength is in problem solving, not in memorization.
Right.
Wow, I love that. I got diagnosed with a learning disorder at 32 years old, and I didn't realize it. And thank God my grandmother put me in piano lessons because it taught me discipline. I want to circle back because we have people in the chat who I don't even want to I don't want to acknowledge certain comments, I think, because it could get beyond the scope of our conversation. But can you explain why cancer is not just one disease and why it's so difficult to treat? And then the second question is about radiation and what are some of the therapeutic benefits? Because we know that there is harmful effects that can come of radiation, but how has radiation been shown to be therapeutic, or has it been shown to be therapeutic? So 2 questions.
So Dr. Melissa, I'll throw that one to you.
Not the radiation question now. You're the physicist. I'll answer the
Why is
question.
cancer so hard to treat?
Why is cancer so hard to treat? Yeah.
So why is cancer different? That's a great question. So, one of the things we're starting to appreciate, and maybe, you guys probably heard of something called precision medicine or personalized therapy, right? No 2 people live the same life and therefore haven't had the same exposures. And so what causes cancer, is a combination of, what is inside of you, so what you've inherited, but then also what you've been exposed to, your lifestyle. And so what drives a malignancy, what gives a cancer cell a superpower, because your body is actually equipped to identify a cell that's sort of out of check or out of sync, and it's supposed to destroy that cell. But every now and then a cell will, accumulate enough alterations or mutations is what we call them, right? That it becomes sort of over proliferative. It divides too quickly. But what's driving that division and allowing that cancer to thrive can be different from one person to another. And one example in breast cancer is when we diagnose breast cancer, one of the first things we identify is what hormone receptors are expressing, because hormones can sometimes cause cells to grow. I mean, just like in normal development, right? Hormones cause our breasts to develop. Hormones causes our our babies to develop, right? So sometimes those steroid hormones, can be feeding tumors, but that's not always the case. And sometimes it's different hormones, right? So, it's just a combination of things that, first of all, allow the cancer to develop, to get the superpower that your body no longer has a handle on it. And then also, some of those internal, but also external factors that make it grow. And because of that, then the treatment needs to be tailored for what's causing it. What is the cause of it? And how does your body respond to the treatment? All of those things kind of create, every cancer patient has a unique scenario, a unique constellation, if you will, of various things that we have to really pay closer attention to in order to actually cure someone of a cancer diagnosis. So that's my first pass on the question number 1, and I'll punt it to the physicist to answer the radiation question.
Let me pause and just say what I heard you say for people watching is, 1, the body has a mechanism to heal itself, right? In general, our bodies can restore and repair damaged cells, okay? 2, when that mechanism gets out of whack, that's when cancers can develop, and there's not just one pathway to it. So there's not just one type of cancer, even though people use that one word. Cancer is not just one disease. Those cells can live forever because a lot of different pathways, right?
It's a big word.
That is.
Yes,
Got it.
And I mean, and where cancer occurs is really how we give it its name, right? So a tumor in the breast is breast cancer, a tumor in the colon is colon cancer, but we also know that there are certain mechanisms that are embedded in those organs that really become what is driving the tumor. It's something about what that organ is supposed to be doing that gets hijacked by the malignancy.
Well, that's interesting. Gets hijacked by the malignancy. So a milk duct that should be making milk gets hijacked by a malignancy. That's a really cool. I love that. I'm gonna write that down. That's crazy.
So I love the way Dr. Melissa, Dr. Monique, the way you guys frame that. And because cancer is describing hundreds of different types of diseases, people assume because we use one generic label that there's one generic treatment, and it's not. And when we are breaking things down so it's easy to understand, it's important to say, let's take a step back and look at it from the 1,000-foot view, that a lot of people say, okay, well, if you change your diet, or if you don't have stress, or if you have an alkaline body, or, you know, if you're not using certain type of products and all of these things, that you won't get cancer. Or, you know, if you have certain genetic predisposition like BRCA genes and things like that, that you know, it's inevitable. But there's only, and Dr. Melissa helped me, I think only like 15% of all cancers are genetic. Everything else is something that's environmental or some kind of
Yeah, I mean, I guess technically I would say sporadic, you know, versus inherited syndromes. Yeah,
thank you.
inherited syndromes are definitely like, for breast cancer, it's about 15 to 20%, right? But we always say cancer is a disease of the genome, but is it what you've inherited? No, it's more sporadic, like what you've been exposed to that has damaged your DNA. One of the things I tell people, you know, is protect your DNA, you know, and there's so many ways to do that, because from what you eat to, you know, sunscreen, you know, any number of things can help you, you know, just making better decisions, not smoking, you know, protect your DNA, because that's what's going to help you not get cancer. Yeah.
I tell my patients two things. One, all cancer is genetic, meaning there's a mistake at the factory. And I'm old, so I use this episode of I Love Lucy where she and Ethel work at a chocolate factory, and the conveyor belt goes wrong, because I work with a lot of older patients and they know. And you know, this episode, and all of a sudden the machine's moving faster and faster, and the chocolates are coming off the machine fast. They're stuffing them in their pockets and their cheeks and their hat. That's cancer. The cells keep growing and growing. But not all the factory mistakes get passed down generation after generation after generation. That's heredity, and that's different. And only a smaller subset of the cancers are that. But even as we get older, I say it's like your eyes. When we were younger, not all of us wore glasses. Most of us probably didn't. And we had really great vision. And as we got older, we had a light prescription, and we got a little older. And now we're in, you know, now we're bifocals. Now we're in transition lenses. Our cells make mistakes as we get older, which is why the risk factors for breast cancer. Number 1 or 2 risk factor for breast cancer, being a woman and getting older.
Right.
You know, God willing, we'll keep doing both.
Right.
And so I think when people internalize sometimes that the environment and the exposures, those are very real components to why we get breast cancer. But I got patients who organic diet, no body fat, exercise daily, do all the things, and they still get cancer. So we can't blame it entirely on those things. And that means it's hard to treat because there's no one single cause for it.
Right. And that leads me to your next question about the different treatments. I think people assume, because they think cancer is one disease, that there's a cure-all. And there's this conspiracy that the government doesn't want to cure cancer. And I tell people, let me offer a different perspective. Maybe the best minds on the planet have been doing the best they know how to do. And maybe the best that they know how to do is to develop the treatments for the diseases that they understand the best. But the same God that created this massive universe where the planets don't crash into each other, that the body chemistry is so complicated that maybe humans haven't figured out how to master it the way we expect it should be in this day and age, because of how advanced cell phones are and how advanced computers are. Well, you know, I like to acknowledge that God is more advanced than the people who created the cell phones and the computers. So the technology for treating cancer just probably hasn't caught up. I don't believe there's this big conspiracy that the government wants everybody to die from cancer, that the methods that are currently available are effective for the diseases that are best understood. And then there are still nearly 9 million people a year who are dying from cancer. And they start combining different treatments and exploring different ways. And you have these different clinical trials and the combination of drugs and chemo and some post surgery options where people stay on certain drugs to make sure that the tumors don't come back or the cancer doesn't come back. And so radiation, to your earlier question, is part of the family of interventions that are being used to combat this very complex set of diseases. And when people see the research that I'm doing with laser activated nanotechnology, if they understand it, or if they don't, they think, oh, the pharmaceuticals companies are gonna assassinate you. And I'm like, they're not gonna assassinate me. I am part of a big community of cancer researchers who, amongst my peers, we are all doing our very best to introduce new ways to eradicate cancer. There's hundreds of thousands of cancer researchers at our annual meeting, where I actually met Dr. Melissa a few years ago, the American Association for Cancer Research. There are thousands of us. It just so happens that there are not as many African Americans with the academic credentials that Dr. Sebi didn't have. So he's not in the club of people who can be adopted, whose technologies and treatments get adopted by the American Medical Association. But there's not like, there's funding for research, and there's a really tedious process that sometimes the bureaucracy may slow down things, but that doesn't mean that there's a conspiracy to keep people from getting the best treatment possible.
Well, we saw that when everything came to the table for COVID too. Let's bring all the forces together to get a vaccine to save the world, you know, and I hope we kind of do that stuff for cancer. But you know, my favorite quote, and I put this in our e-blast, is Albert Einstein: "A problem cannot be solved within which the framework it was created."
So, and that's
everything.
Yeah, I love that. And so my perspective as a physicist approach treating cancer very different. And back to the bigger question about radiation. So using radiation is like using a big spotlight on the body to say, whatever chemo doesn't kill, whatever surgery may leave behind, that we're going to use this big spotlight and shine it in the area and give this big blast with the intention that we will kill the cancer cells. The problem is that you kill a lot of healthy cells as well. So the technology I developed is like converting this big spotlight to something that's very targeted within the circle of a laser pointer. So it's a targeted therapy instead of a regional therapy. And I tell people, if you put a nuclear bomb in a neighborhood, yes, you will take out the house. But what I'm doing is I'm sniping through the window to just take out the one bad guy. And so, it's a very targeted approach. And one day, once we have the funding that we need, we will begin the human trial process to go through the same standard that all FDA approved drugs go through and all medical devices go through, and get the legitimate stamp of the FDA, the American Medical Association, and to be covered by insurance companies, Medicaid and Medicare. And it just so happens that in our community, people don't see a lot of inventors who look like us. And so it looks like I'm the only one trying, but I'm not. I'm part of a larger community, and radiation is one of many approaches to treat cancer. And so is my technology. It's not a cure-all for all types of cancer, but I developed it for solid tumors that may be chemo resistant or, okay, why can't I think of the word? Recurrent.
Yep,
so
I gotcha.
Yeah, and so I'm not competing with the pharmaceutical industry. I want to dispel that myth. I'm not displacing anyone. There's still nearly 9 million people a year who are dying from cancer who need an intervention like mine. And that's where I plan to start.
Love it.
And I want to add to that. Oh, I'm sorry. Go ahead.
No, you go right ahead, Dr. Melissa.
I was going to just say, you know, what we also know about that constellation of causes is that there may be a constellation of approaches that we might have to take, right, in order to truly cure someone of cancer. So it won't just be surgery. It won't just be a pill. It won't just be an infusion of chemo. It could be, a combination of things. And, one of the things about Dr. Green's targeted therapy is like it's sort of the physical targeting, right? Like she's going to hone in on like the specific boundaries of the tumor, like literally where it is physically in your body, right? But what, targeted therapy that I'm developing is more molecular targeting, right? Where I'm actually looking at what genes are upregulated. And then, those two different types of technologies could be married or converged
Yes.
down the line, right?
Right.
Because then her laser is sort of being pointed at, it's literally like war, right? Like you point the laser, I'll drop the bomb's
Right.
gonna go
Right.
where the
Here we
laser's
go.
pointing, you
Here
know
we
what I
go.
mean?
Hey,
Yeah,
listen,
so
just count me in for the cleanup on surgery. Once you guys do that heavy lifting, that means that I don't have to do a mastectomy. Maybe that means that maybe my
I
surgery can
know.
be smaller. That means that my
Yes,
margins can be clear. And I
yes.
wish that people watching would take that away. That when a person gets diagnosed with cancer, I explain to them that there's a whole team and there's a very personal approach, such that one, the person that you may know who had the same stage you had may get a different treatment. And it
Right.
can be very confusing because you're like, well, so-and-so had stage 1. Why do I need chemo? My tumor is only this big. Why do I need certain things? But there's a whole team of doctors who sort of work together, not sort of, we all do. We work together to treat cancer from different ways, to prevent recurrence, and then to treat if, God forbid, a recurrence happens. And so this is some really juicy stuff. You guys got to get into this because it's not just a menu where you pick and choose. Well, I'll do this, but I won't do that, but I won't do that. It's exploring with your doctors. How do these therapies work together? How do they all work together? And that's what we got to get to as a patient, as an advocate, is helping our family members have that conversation so that we don't just think, well, this is the one thing and I'm not going to do the rest of it, because we want to prevent recurrence. We want to see long life, contrary to what anybody might think about cancer doctors. We are in it for our own personal reasons, right? Like Dr. Green, tell some more of your story if you get a chance. Dr. Melissa, tell your story. I'm always telling my story about my loved ones, my mother, my grandmother. Like, this is personal for us.
It is. And like for me, you want to go first, Dr. Melissa? Okay. So for me, I was raised by my aunt and uncle. My aunt was the only mom I knew, and she raised me like one of her own children. And, I became the first in my family to go to college. And the day after I graduated, she announced she had what she referred to as woman's cancer. And she didn't tell a soul. She said that she would rather die than experience the side effects of chemotherapy and radiation. And I was her primary caregiver the last 3 months of her life. And this is how my story began. Seeing the matriarch of our family, the cooker of Christmas and Thanksgiving dinner, our prayer warrior, the glue that held our family together, deteriorate to the point where she couldn't even walk. She couldn't talk. She couldn't bathe herself. For her to feel humiliated at the hands of cancer and feel helpless and powerless and deflated and ultimately succumb. She wasn't a survivor. And then 3 months after she passed, my uncle who raised me was diagnosed with cancer. He opted in for treatment, even though with treatment, they told him he only had 4 to 6 months to live. And it fell on my heart that there has to be a better way. And so for all the women who see this, who don't get mammograms, who don't do breast exams, who are not taking care of their breast health, please understand that if you get breast cancer and it's diagnosed at stage 1, stage 2, and you get the treatments early, you will live to die from something else.
Curable. It's curable.
It's curable. It's curable. So when women are coming to me saying, I don't want chemo and radiation, I want to wait on your treatment, it's like, absolutely not. There are cures now that can save your life now. So don't wait. Please don't sit around and wait. Be aggressive with your treatments and your response to a diagnosis. Don't live in fear. Don't live in shame, because there are options that are available today. Sometimes, women are saying, I don't want to lose my hair. I don't want to lose my breast. But the people who love you don't want to lose you. Right. I lost my aunt when I was 22 years old. And I look at Ricki, who is now a grandmother, and she's seeing her kids grow up, and she's seeing her grandbabies grow up. Like, that makes a difference. So when you're making selfish decisions about not getting treatment, think about the people who love you, who you're leaving behind, and make the choice to get the mammogram, take the treatments, get diagnosed early. Choose life.
Choose life.
Yeah.
Choose life.
And you know, I want to add on to that because I think that people always interpret what we mean when we say get the treatment and choose life, that we're saying, you know, abandon the things that we culturally believe about how our food can be medicine, about how our bodies can heal themselves, because that is a very real conversation. I know we've talked about it on this show quite a bit, and we'll do some more talk about nutrition and about DNA repair and about ways to optimize our bodies for wellness. But if you believe that your body can heal itself, then surely it can heal itself from chemo. Surely it can heal itself from the effects of the treatment, because sometimes we need a little bit more in order to treat a cancer. By the time a tumor has formed, our body's ability to heal itself is already impaired. We're already behind on our nutrition sometimes. Sometimes we're already behind on the ability of the body to repair itself, and we got to get caught up, but we mistake that maintenance for the cure, and then we lose out.
Right.
And that doesn't displace the importance of prayer. And I know in our community, our faith life, sometimes it's complicated and people think, oh, I'm going to pray it away. And God gave us doctors. God gave us interventions. God gave us options and technology. So take those blessings and don't be the person that prayed for God to answer a prayer and God sent somebody on a raft and then sent somebody on a boat and then sent somebody on a yacht, and you keep saying, I'm praying for God to show up, but God sent all these ways to help you not drown, and then you drown and die and get to heaven and say, God, why didn't you help me? And God said, I sent the person on the raft and the person on the boat and the person on the yacht, and you were too stubborn to realize that was me showing up for you. So don't get stuck in what you think it will look like for God to show up.
Right. Faith without works is dead.
Yes.
Faith without works is dead.
And the other part of it is that when we're at the table, we're not on the menu, right? Because here we are, scientists and researchers and physicians and advocates, you know, we get to have a say in how this goes for us and how this impacts us.
That's right.
And, you know, Dr. Green, one of the things, Dr. Melissa, and one of the things I love about what you all are doing is you're trying to find ways to optimize this for patients so that it's not all out of pocket and expenses for patients, and that it doesn't all come from, you know, sources that may have special interests. You know, Dr. Green, I think a lot of the work that you're doing has such integrity to it, and that matters. It matters a great deal.
And a lot of people don't understand. That's why I started a nonprofit instead of going for profit with my technology. A lot of people who develop technologies, the traditional path is to start a for-profit, take investors, and then sell to the pharmaceutical industry. And then they dictate how much things cost based on the market rate. And when I looked at that path, I said, oh no, and I got really convicted. Like, shame on me for being the first in my family if I develop a technology and even my family can't afford it. So I decided to start a nonprofit inspired by Susan G. Komen. And I said, if they can raise hundreds of millions of dollars in the name of finding a cure for cancer, surely I can raise the money I need through my nonprofit, the Aura Lee Smith Cancer Research Foundation. And with raising the money independently through my nonprofit, it gives us this concept that my soror, Shirley Chisholm, said, unbought and unbossed. So if we're not selling out, we can dictate how much we'll be able to charge or have a sliding scale and ensure that my technology is affordable and accessible for all in the United States and abroad. Because our community at large in the Caribbean and on the continent of Africa, like, they need help with cancer treatments too.
Right.
Absolutely. And somebody brought up in the chat that men get it too. And we know that although men are less than 1% of breast cancers, in particular, Black men are more likely to get breast cancer. I forget what the percentage rate is, but it's at least twice, if not more than that, and more likely to die, 40% more likely to die of their breast cancer when Black men do get breast cancer. So it's important not just for women, but this conversation is for men. We should be talking about this with our young men and our young women. You know, hashtag check your chest, right? Hashtag check the breast. How do you say it, Ricki? The breast that you love?
Yeah, check the breast you love. We know you have a pair. We know you have a pair or multiple pair. Dr. Melissa. So Dr. Melissa, you know, she spends a lot of time working on triple negative breast cancer, which, you know, is my passion. And I don't know.
And we want to hear her story too, her backstory.
Oh yeah, that's what I wanted to get her.
Absolutely.
Okay, share her story.
Well, I have multiple stories. You know, I have the story of what got me into genetics because we didn't have enough representation. I mean, you know, going all the way back to the first thing you said, you know, about not testing well. I got a C in genetics in undergrad. You know, I got A's in everything else, but you know, botany, you know, biochemistry, whatever. But the worst science, my
Organic
worst grade
chemistry.
in science
I
was in
took it twice.
Yeah, I had to take organic chemistry twice too.
Right.
That was my
I
worst
used to do
class.
organic chemistry. It was rough.
I call it cosmic redirection. The universe just
I
teaches you
know.
got to study a different way. You got to think
I-
about how you
listen.
learn. It's possible, people. Tell your children, tell the kids, it is possible for them to be scientists and geneticists and surgeons and researchers.
That's right.
Right.
That's right. And yeah, so like for one of my projects, I saw like they had discovered some gene that was for aggressive behavior, and it was, oh, by surprise, only in, you know, the Black people in their study. And I was like, nah, I don't understand what this is, and I don't believe it. Let me get deeper into it. And then as I went through my training and my postdoctoral training at Yale and University of Chicago, I noticed, you know, in some of our discoveries that, or some of our research projects that we were seeing that women of African descent, both African Americans and Nigerians, so people from West Africa, were primarily presenting with a certain type of tumor. And this type of tumor didn't have a targeted therapy. And then when I dug a little deeper, like, well, why doesn't it have a targeted therapy? Well, it turns out that most of the research that had been done to develop targeted therapy didn't include that population that had triple negative breast cancer. And so I was like, all right, Lord, I see my calling, I see the path I am on, and that became my conviction, you know. So you know, just calling something what it doesn't have is not at all useful in terms of trying to cure it or develop a treatment for it. And so that's what we do. You know, we redefine triple negative breast cancer in multiple ways and really trying to uncover, you know, what is it about our shared ancestry that could be driving these more aggressive, you know, tumors. And it might not be the cause of the cancer, but just why the cancer grows so rampantly when it does develop. So that's my story in terms of, you know, why I'm interested in it. And I mean, I guess, you know, in my family, my grandfather passed from something that in his medical record says cancer of the bowels. What is that? Is that colorectal cancer? Well, I mean, if I think back to when we took care of him, because my mother was his primary caregiver and I had to help her and I was in high school. From what I know now, I think he actually had prostate cancer, right? But it didn't get diagnosed like that because, you know, he was in Blakely, Georgia, in that's Southwest Georgia, and he didn't have a primary care physician, right? Until his daughters, who had, you know, gone through some level of education, helped get him into Albany, you know, which was at that time the big city, right? But this is still a small town, Southwest Georgia, and it's like, you know, the systemic racism and, you know, unequal access to, you know, care, deprioritization, you know, all of that sort of coupled into what I understand now about the way, you know, cancer research happens is why I got into this. And why I think I've been successful, because, you know, I'm not doing this for myself. I'm not doing this for profit. I'm doing this to change the world for my people, honestly, you know. So
well, you say something, Dr. Melissa, you talked about how when you started, there weren't any scientists in this arena. And guess what? Black women get triple negative at twice the rate of white women. So for us not to be considered in the research is crazy. So, I mean, thank you. And I applaud you for reaching out to do this with Black women, because we don't know. I mean, you're doing this for me because we don't know if TNBC is hereditary. You're doing this for Belle and for Amanda and for my girls. And for
my daughter, yes. My Malia, yes.
I need you to do
this for me. Shoot, you know, I got family history of breast and ovarian cancer. The work you're doing, it could be saving my life. So
all of our lives, and that's why it's so important, because, and a lot of people don't understand when they're looking at the national ages that things are recommended for white women. It's different for Black women. Like I know women. I'm 40 years old now, but I know women who got diagnosed with triple negative breast cancer in their early 30s and died.
Oh, we have Ari. She's 19. She didn't die yet, thank God, for she's healthy, but she got diagnosed at 19 and fought it twice. So it's
Wow.
hitting us at a young ages, and we have to get rid of it. We have to. So
So we can,
you guys are miracle kids.
And just because the talk today is about research doesn't mean that we're only thinking of research as the only way to battle this disease. And I think I want to point that out again for people, because we get a lot of questions. Well, what about the nutrition? What about the this? They may be beyond the scope of this topic today, but they're important conversations to keep having and to keep asking your doctors about. And if your doctors don't have good answers, you've got to keep asking, because we know that there are more ways to optimize our bodies for wellness, and that nutrition should be part of it. And getting good rest should be part of it.
Yeah.
The impact of stress on the body, our blood sugar, diabetes, all these things impact our body's ability to, one, tolerate treatment, two, recover and rebound from treatment, and three, stay well.
yes.
Absolutely. Mental health is also very important where that's concerned, you know. We know that psychosocial stress can actually drive hormones, right? That could actually feed your tumor. That's why I tell people I'm allergic to stress.
Yes.
I'm a Black woman, you know, the odds are against me that if I get cancer, I'm going to get a treatment that's going to cure me. So I'm going to have to be, you know, preemptive. You know, if you have too much drama, you got to fall back. I cannot.
Right. I'm the same way. It is not welcome in my life. And the other part that I want to add, when people don't understand the importance of exercise and how that helps regulate your hormones and how it lowers your stress and it helps you sleep better and getting more water and eating more fruit and vegetables and reducing your fried foods, and anything that's unhealthy with a whole list of chemical ingredients that you're eating, that's not of God. That's not giving you wellness. And even though it may have the labelless food, we need to redefine what food is. Food are things that have nutritional value that come from God. Things that are chemical and man-made, you may eat, they may taste good, they may fill you up, but it is not designed for your overall health and wellness. And don't be confused and misled if you cheat and enjoy it, but no, that's what it is. It's a cheat for your enjoyment. It's not designed for your health and wellness.
Yes.
So Melissa, what are some of the things you're doing in the lab right now? Like what is some of the work you're working on? Describe.
You know, my favorite project right now is the dark side of cancer, right? The dark side of breast cancer, which has traversed into prostate cancer now as well. But so that work has to do more with the immune landscape, and why, as people of African descent, having this mutation in a gene called DARK. The mutation is Duffy null. Duffy null is actually a blood group, and it was fixed in our ancestors in sub-Saharan West Africa because it conveyed an immunity to certain types of malaria. Well, the consequence of this mutation is that we do not regulate inflammation very well. Okay, so that means that if we're carrying this ancestral allele, then we have chronic inflammation. And any disease actually that has a component of inflammation is more severe, right, in African Americans. And so what we're doing is focused on how, you know, that chronic circulating systemic inflammation, even before, you know, cancer, but certainly during the course of, you know, tumor development, can alter your immune cells. Like we're seeing this signal of what we call exhausted T cells, and it's literally that your immune cells are tired and they're just not doing what they're supposed to do. They have changed because the environment that they've been developing in is oversaturated with all of these things, all of this inflammation. And so that's what we're studying right now is, you know, the consequence of all of that in tumor progression and how we can target it for treatment. So that's my favorite. But, you know, we're also doing, you know, things around BRCA. We found a new BRCA allele that appears to be in our Ethiopian and Ghanaian patients. We think that it may be a variant that could be a targeted indicator for, you know, a PARP inhibitor therapy. We're also looking at, you know, a host of other markers that I don't want to get into because, you know, I don't have my slide deck. So.
Oh, good.
Oh my God.
I think I heard you say something really important though, because you said something about inflammation causing or setting the stage for cancer development. And Dr. Green, I wonder if you can rattle off some diseases that are associated with inflammation in the body that people watching might not even be aware of, that's inflammation inducing, right? What does inflammation do to the body?
That's Dr. Melissa's expertise. Let's throw that question back to
Okay,
her.
got you. Dr. Melissa, any doctor, yep.
Well,
Some
I mean, so
diseases
for
of
instance,
inflammation.
severity, so inflammation is really when, you have an infection, right? So even a paper cut, right? So that area that gets red and swollen, that red swollen, sort of tenderness is inflammation. And what that does is basically activate your immune system to say, there's a foreign, there's something bad. We need to go to this area of the body and get rid of the bacteria. So these are signals for the white blood cells, specific types of white blood cells, to go to an area to defeat whatever the foreign body is. It is also what happens, for instance, when you have a respiratory infection. So, in COVID, one of the things we heard about was this cytokine storm, this high level of inflammation, and that was what was driving mortality early on during the peak of COVID, right? So your body automatically has this peak of inflammation in response to infection, also in response to tumors. But what happens is you want that to be a peak that comes right back down, so you signal, you alert, and then you turn the alarm off and the system does what it's supposed to do. If inflammation continues, that's like the alarm. You know how you get the car alarm and it just stays on so long that the battery dies because nobody ever turns it off, right? So that's what chronic inflammation is, right? That the chemokines and the cytokines that are supposed to just be at a peak, at a spike, and then come right back down, they stay high too long. And that source of inflammation can come from obesity. It can come from side complications from diabetes. It affects things like asthma. So for instance, that asthma attack you have is actually, related to inflammation. I'm blanking on other things right now.
Heart disease, gout,
Heart disease,
thyroid
yes,
disease,
gout,
diabetes, cancer, you name it. Inflammation is a
Yeah.
source of illness, even in our gut. When we talk about, we're going to do a show on bacterial translocation in the microbiome, but
Yes.
even the bacteria that lives in our bowels, which is why we talk about good bowel health and good gut health, can seep through the walls of the intestines and into the bloodstream and create little places in the body that cause inflammation, that sets up a nasty little environment for cancers to happen. Inflammation is everywhere.
Yes.
Everywhere. So this research is huge, Dr. Melissa.
It is.
I hope so.
I'm like fangirling because she is so brilliant, and I absolutely like love her research. And then let me say, when I was starting off, I would read about people like Dr. Melissa and get intimidated because I didn't understand the cancer biology. And the questions that I had was, why, if cancer is in the breast, why not just treat the breast? Or if there's, cancer in your neck, why not just treat the neck? Why put chemicals throughout the entire body? And as I developed in my understanding, I grew to understand it, but starting off as a physicist, it didn't make sense to me. Why not just target something that we know will kill cells like heat or something cold? And, there's cryotherapy, there's thermal therapy, and understanding what's wrong with those. And if we put the same effort behind developing that kind of intervention, the same way we put behind developing chemicals, then maybe those interventions could be more viable options. So my approach isn't based on biology, but I understand how critical the biology and the chemistry of cancer is. And my approach is based on physics and the physical intervention. So it's not actually cancer type specific. So sometimes if cancer metastasizes or migrates to another part of the body, the cancer drug may not also treat it in that next location. And so sometimes metastasis is difficult for people to treat because it shows up differently. But with my intervention, not that I'm saying it's a cure-all again, but with my intervention, it doesn't matter where the solid tumor is. As long as we can get to it with the scope or with the laser that can penetrate up to 10 centimeters, it doesn't matter if it's breast cancer, prostate cancer, head and neck cancer, lung cancer, oral cancer. If it's a solid tumor that will respond to heat like everything in the body does, if you burn something, it will die. And if we can localize the burn to just the site of the tumor, it's an ablation. It's a way to kill locally. And that doesn't take away from the beauty and the brilliance of targeting the molecular structure and the biology and the chemistry of a cancerous tumor. Like those are different approaches, but like Dr. Melissa mentioned earlier, what's really cool about it is when we can have interdisciplinary research and interdisciplinary approaches, like Dr. Monique was saying earlier, like that is where we really make leaps and bounds forward, where instead of just only treating solid tumors, I can link my nanotechnology to tumor targeting antibodies or tumor targeting ligands that can connect to a specific biomarker. And now we can, you know, target different types of cancers in more creative ways for people who need other interventions. And so this what we're discussing about research, it's like people see innovation all the time, every time a new iPhone comes out. And what we're doing now is trying to get the new iPhone in cancer research.
Right. All things work together for good.
Yeah, I'm a Star Trek fan. I'm all about it. You know, bring out the tricorder, and you know what I mean. Like I'm ready. Let's do it.
I need to point out to people watching that a tumor can be millions of cells, and we're talking about particles that are so tiny. Nano. Tell us what the nano.
Yeah. What in the world is a nanotechnology? What is a nanoparticle? So nano is a unit of measurement. So people hear nanometers is a size, like people are used to millimeters or centimeters or a meter stick, right? And so when you look at nano, is 10 to the minus 9, where centimeter is 10 to the minus 3. So you're looking at something 1,000,000 times smaller than a centimeter. So if you imagine the back of a penny and Abraham Lincoln on the back of a penny inside the Lincoln Monument, and you imagine his eyelash, and then something that's like 1,000,000 times smaller than that gets you to the nanoscale. This helps with the precision of the treatment that I'm developing. And so these nanoparticles that I created, I developed a fabrication technique, a way to make these nanoparticles, and I'm using gold that's inert. By itself, it's completely harmless. It doesn't kill anything by itself. And I create them so that they absorb light at a certain wavelength. And the wavelength of light that I'm using is coming from a laser that is harmless like a laser pointer, very low power like a laser pointer. And the laser by itself is also harmless. And only this specific small range of wavelengths that the laser is emitting, when it shines on the nanoparticle, if it's around whatever it's touching, it's only activating the nanoparticle. It's not actually, the laser itself is not killing any cells. The nanoparticle by itself is not killing any cells. Only when the laser activates the nanoparticle by a physics concept, and then just teach you guys a little bit of physics called plasma resonance absorption. And that may sound like a big tech term, but the bottom line is like when you blow a dog whistle, only a dog's ear can hear it. And it's like my nanoparticles can only hear the laser. And this is the concept. So when I was learning physics, when I was learning about these things, I had to take like a separate notebook and create like my own dictionary of how I understood the terms. And so being able to wrap my mind around plasma resonance absorption, it's like, this is a missing link and what some of the other people who had done this before didn't optimize. And then I have another technology where I developed how to conjugate or attach my nanoparticles to antibodies that target biomarkers that are overexpressed on certain types of cancer. And it's not that I'm the first person to do it, but I had the ability to focus and concentrate long enough to optimize how that's done so that I'm using covalent bond chemistry instead of just regular positive, negative ion attractions, because covalent bond chemistry is more like a lock and key. And it's like, when you do that, it's stuck. And so developing these technologies and understanding the physics behind it, understanding the chemistry behind it, and using nanotechnology as a way to specifically target the site of the tumors and just that very local area is just a different approach that I could tap into my strengths which is not the biology of how cells are upregulating and downregulating and overexpressing. And like, I understand that part is so important, but I had to bring my strengths to the table and partner with people like Dr. Melissa so that we can create better technologies for everybody. And it's not a competition.
No, it's not. No, I feel like that's one of the things we try to like break down the silos, because there are so many silos, and there shouldn't be, because we're all in the same sandbox trying to get to Oz where there's no cancer, right? So
I'm saying, I'm glad to see you, Dr. Green, because look, I took physics and it wasn't pretty. So, you know, I feel like, you know, just like you said, you know, like you may not know the depth of the biology or the genetics that I know, but I don't know the depth of the math, right, and the physics that you are doing either. But we couldn't possibly know everything to that depth, you know what I mean? Like we have to specialize and then work together. And I might scream because there's a chipmunk running towards me right now. I loved your explanation of the physics, and I think that is very important that, you know, as Black women in STEM discipline, you know, that they hear that you know, our communities hear more about what we're doing at this phase, so that when it's finally funded, you know, and it's finally available in clinic, they'll know, you know, all of the hard work that went into the development of the technology, so that it's not like something apprehensive, like, what is this, you know, they just made this up yesterday just because you just heard about it.
Like the COVID
vaccine. Right. Yeah, exactly. Right. Yeah, exactly.
It's true. My two best friends in college were physics majors, and they both went on to get their PhDs in physics from Florida A&M. Well, they got their graduate degrees elsewhere, but I mean, it's an amazing discipline. And I love what you said, Dr. Green, and that you found your niche. You found where you could bring your skills and your talents. And I think that's what the universe requires, right? That's what God requires of us. Everybody has something that is unique about you and your gifts, right? And amplifying your gifts to try to cure cancer is huge. But Ricki, did you hear her say 1,000,000 times smaller than an eyelash? Did you catch that?
I know. I got that.
Yes.
1,000,000 times smaller than the eyelash of Abraham Lincoln on the back of a
penny. I know.
So no.
But I think you guys are all like you think differently from most people. Like you're thinking about things that don't exist, things that there you're seeing gaps of things that where you can bring your strength and your brains to the table in a situation where somebody didn't see it already. And so that's what's so impressive to me, because this is over my pay grade. But I mean, like I think you guys are just, well, we can't make it without you, and our future is in your hands. Our future is in your hands. So when you go to work in the morning, you're working on something that is going to change lives, and it just blows me away, and I so appreciate you.
This is why I love Ricki. She's like the best cheerleader. She always tears me up. Like if I ever forget why I'm doing this, it's like just tune in and get a little of Ricki's love. And it's just like, and it's humble.
The warmth of the sun, isn't it? It really is.
It really is.
I need you.
And I know for every Ricki I know, there's millions of Rickis that I don't know. And that's what keeps me humble about doing this work. This is the Lord's work, and it's sacred, and it's, you know, people say, well, it's a huge burden, but it's a huge responsibility. I don't look at it as a burden. It's an honor and a privilege to serve on the planet this way, and to be able to use the brains God gave me, because I could have been doing, you know, mathematical models for the International Space Station or something else, which is still cool. I could have been developing faster, better internet and cable and cell phones, which is what I thought I was going to do when I blew my knee out and realized I wasn't going to be the next Jackie Joyner-Kersee. But but this is a privilege to be able to use my intellect that God gave me to work and try to solve a big problem like curing cancer, and to have technology that's already showing that is complete elimination of human cancer in laboratory mice after one treatment over 15 days with no observed side effects. And to have the path, the next step being raising the money to begin human trials is humbling. And I'm excited about the journey. And, you know, I know some people may have questions. We are currently not taking any cancer patients. We are still raising money to begin human clinical trials. If people want more information, you can.
What's your, I'm putting it in the chat. What's your website?
Okay. Thank you. oralee.org, ORALEE.org is my website, where people can follow us on social media at Dr. Hadiyah Green, at oralee.org, to help support us. We need volunteers to help us with marketing and fundraising, to help us get the word out. We are on the brink of beginning human clinical trials. So before all the cancer patients and the ones who've been reaching out to me already, because we've been trending over the last week, we're not open for clinical trials yet. We're raising money. And I know some people think, well, when are you going to start? How long does it take? It's not about how long it takes. Clinical trials are expensive. We're committed to staying independent of the pharmaceutical industry so the technology can be affordable for all. So we're not taking shortcuts. We're literally dollar by dollar raising the money, and in the background we're writing grants, and I'm you know, competing for federal funding, but only, and Dr. Melissa, you can vouch, like sometimes
Research costs a lot of money, doesn't it, Dr. Melissa? I mean, you're doing the same thing.
Yeah, absolutely. I mean, and let me tell you, it's hard. It's difficult, especially if your goal is to help minoritized, racialized populations.
Yes.
It's really difficult to get, you know, federal funding. I just got my first major NIH grant literally like last month, you know.
Congratulations.
So, thank you. I know it's a life-changing experience. Let me tell
That's
you.
huge. That is huge.
Yes,
like, let me just pause.
yes.
That is huge. Like, if you
Huge.
look at all of the cancer researchers on the planet in the United States, whether you come from Princeton, Harvard, Yale, Stanford, any Ivy League school, to get NIH funding from the National Institutes of Health, it's less than 20%, sometimes even 10%.
It's less than 5% if you go by the pay line, right? Like,
That's right.
Really
Right.
really
Yes.
difficult.
And so for you to do that as an African-American woman, like, that's trailblazing. And in cancer research, that does not happen often. Like, we need to give you your flowers now.
Thank you.
We can't just rush past that. That is awesome.
Thank you for your magic touch, Dr. Melissa.
Magic touch, right?
Wow.
Yes, I have a great team. I mean, we're really excited. Like, I'm ready to go full scale because, you know, like Dr. Green, you know, it's like we're always on the precipice. Like, if I just had enough money to like do this at a larger scale, if I just had enough funding, enough support, enough infrastructure, right? So that I could actually go to the next level. And now we finally like are starting to get it. So, you know, it's going to be a phenomenal next 5 years. Like, I can't wait. I literally am so excited. I'm so excited.
I'm excited for you too.
Wow.
Yes.
That's awesome.
And I'm putting your email in the chat too.
Okay.
Yeah,
put my Twitter, Melody32.
Okay.
Yeah.
Oh, yeah.
That's
Will
my
do.
email.
Yeah, she's my Twitter sister.
Yes.
Mine too. Dr. Green, give us some closing parting thoughts on what you think the future of cancer care could look like, and like, what's your hope? What gives you hope when you get up in the morning, and what can give people hope who are going through their cancer journeys right now?
That's such a profound question. So what gives me hope when I wake up in the morning is that I know I have a higher calling, that I'm not limited by what man thinks is possible, that this is a divine assignment for me. This is the Lord's work that I'm doing. And I don't have to think about whether man is saying yes or no, that this is something that the Lord ordained and fashioned my life to make a priority for me to do this. No matter when it happens, this will happen because I know this is my divine assignment. That keeps me going. That gives me hope in the morning. For cancer patients, people who are diagnosed with cancer right now, I would like to just encourage everyone to know that even though earlier I said God gave us the doctors are still not God. So don't let anybody give you an expiration date. You know, you don't know what God has for your life. And the best thing that you can do is to fight to stay positive And the battle of the mind is such sacred grounds that once you give up in your mind, your body and your spirit will be obedient. But if you keep that fight, that positivity, that God is the author and the creator of life, and God says when, not the doctor, not a diagnosis, not what your body feels like that day, but God says when, and you can go on to live to, for years to come. So keep your mind positive. And prayer has been scientifically proven to help improve outcomes.
Right. Amen. Amen.
That's
I know
right.
prayer got me here where I am.
Wow.
Yes.
Well, Ricki, this has been an amazing show.
Yeah.
Dr. Green, thank you. We hope to have you back to talk some more about your research, about ways that we can support you, about all of this. This is
And
amazing.
let me say,
Let Dr. Melissa give some thoughts, closing thoughts.
Can I say one more thing about what I envision for the future? Like, I envision a future where women don't have to lose their breast in order to eradicate their breast cancer or eliminate their breast cancer. I envision a future where women don't have to lose their hair to get treated, where when people get diagnosed with cancer, it's like being diagnosed with now AIDS. Like, oh, I can live with this forever. I'm not going to die. And it takes the knowing that there are viable treatments and you can be cured, it takes the fear out of it. That's the future that I want to see, where cancer is just another thing, like, oh, let me get that zapped or taken care of. I don't have to worry about it. And I can go on and live to die from something else.
Oh, I love it so much. Dr. Melissa.
Yes, ma'am.
Close us out.
My closing remarks will be, don't let your circumstance define you. Don't let anybody's opinion of you change who you know you are. And, your perception of the world is limited to your perspective. You know what I'm saying? So, like, if you feel like you're in a place where you can't thrive, then you need to make some moves. And I would just like to just add that, what I'm doing currently in the world didn't even exist when I was, in school trying to figure out what I wanted to do, right?
Amen.
So, don't let your current situation today, defy what the Lord has for you, and also just what your destiny is, what your calling is, what your talents are, strive for a better tomorrow. And for cancer patients, I would say, you have a team of people beyond those who are around you, who are fighting for you, including me, Dr. Green, our teams, our colleagues. It's a whole world of us out here trying to make sure, that you can survive this diagnosis. So, have faith.
Thank you. Thank you. Oh, you guys. Oh my gosh, what a way to spend a Sunday afternoon. Thank you. Thank you. Thank you. Have a great birthday party for your baby. And guys,
thank you.
Thank you so much. We have to do this again because we got to talk about science all the time. So
I would love to. Yes.
Yes. Thank you for your magic touch. Thank you for your magic touch.
Thank you, ladies.
We hope it's been relatable and reliable and real. That's what we set out to do every single Wednesday and Sunday here on blackdoctor.org. And we thank you, blackdoctor.org, for the platform.
Thank you. And thank you, Amgen, for always helping us out, being there for us.
The doctor is in.
Breasty love.
Breasty love, everyone.
Breasty love. You're on your phone. Breasty love. Take care.
Take care.
Bye.
Love you guys.
Oh, there it is. I love it. She got it.
She got it.